So what we're showing you here is a quick snapshot of exactly how the data store is performing as a whole. So you'll see we're giving you the key metrics such as IOPS, throughput, we're even giving you information about the latency on the system. And we break the latency into multiple components. So latency that's been induced at the host system, what's been induced by the network, and also what latency has been induced by the storage system itself. And I can actually click on any of those particular boxes and we can get even more information about the data store. So what you'll see here is, this is actually the total IOPS on the system at this precise time. What you're seeing here is the relationship between not just the total IOPS but the read versus write, and you're seeing who the top contributors are. At any point on the graph I can click, and not only will it tell me who the top contributors are, it will actually tell me the one VM that is actually generating the most amount of I/O. Now that's for IOPS. I can also look into throughput, I can look at latency, but what tends to be more interesting is understanding more about how the system is performing from an individual virtual machine level.
That's right, yeah.
So here you'll see...
Per VM level, actually.
So here you'll see a whole bunch of VMs on the right-hand side of the display here. This is really showing us which VMs are busier than usual. So either in terms of the performance, i.e. the IOPS they're consuming, or the space that they're consuming. The other cool thing that you're seeing from the dashboard here is we have these two fuel gauges. The bottom fuel gauge is like traditional storage. It's showing you the amount of capacity on the system itself, how much is in use, and how much is free space. But I'm sure you're familiar with this. When you roll out extra VMs, you think you've got space available, so you carry on rolling out the VMs. All of a sudden, performance is really bad for those VMs, and potentially VMs that were previously running fine, and it generally turns out that you've run out of IOPS. And no storage array typically tells you that very clearly. So this fuel gauge here that you're looking at here is essentially a measure of performance. So we're tracking the IOPS, we're tracking how we're using SSDs and hard disk drives as well, and we're able to produce a fuel gauge that's telling you how much headroom is left from a performance aspect. So as long as you have free space here, this green bar, and free space here, this green bar, you know reliably you can add additional server VMs or virtual desktop instances. So it takes away all of that guesswork, it makes capacity planning really simple. Now, we mentioned before that we can go in and look at individual virtual machines. In fact, our unit of storage currently is a V-disk. So the system itself connects to ESX as an NFS-based data store. NFS is really important because it gives us the visibility at the file level, and obviously the most amount of IOs we're going to be seeing generally generated from those VMDKs. So they're very important, we're able to see those, and NFS is a great medium for being able to do that. So here we'll see a display of the VMs. The names as you see them are exactly as they would appear in vCenter. So no complex UUIDs attached to the name of the VMs. And you'll see here some key metrics that we're looking at. If we're interested in which VMs are generating the highest IOPS, if I just simply click on the IOPS tab, you'll see instantly we reorder the list in terms of IOPS. We can do the same for throughput, and we can do the same for latency. In fact, if I right click on this particular chart, there is a whole raft of metrics we can report on if you're interested. Most of our customers tend to be interested in IOPS, throughput and latency as being the main ones. And from there we can start to go in and grab more information about the VM. So we can right click and then there's a whole raft of different options. So we'll start by graphing this particular VM. So now at the VM granularity we can see the profile of traffic on this particular device. So if I click on any point in time here, you'll see that the IOPS count total was about 8,500 IOPS for that VM, of which just over 4,000 were read IOPS and also just over 4,400 write IOPS. So we get a very accurate profile of what's happening here. If I double click on any of these graphs, what you'll see is the screen update. This is a 24-hour viewpoint. We've now gone back to a full 7-day viewpoint. Now I'm sure you're familiar if you have problems on a VM. Let's say for example you've got users that come in at 9 o'clock in the morning and say my application was running really badly at 2 PM yesterday. It's not the easiest thing to triage and understand where that problem was. But we're actually showing you the profile of this traffic for the last 7 days. So you can go in and select things like latency for example, and then we'll get a breakdown of what the latency profile looked like. And in fact we can see a big spike here. So just click on there for a second. Front is medium. What you'll see is that actually in terms of latency, the vast majority of latency at this particular time interval, the total latency was 6.44 milliseconds, but 6.12 milliseconds of that was actually being induced at the host system itself. So we can see that it wasn't a network issue, we can see that it wasn't a storage issue. So very, very simply, we can pinpoint where in the infrastructure the problem lies. Now at this point, most of our customers will be using vCenter obviously to manage their VM estate. Most people will jump straight onto vCenter and start to analyse that particular host system itself, and they'll be checking for things like the number of virtual CPUs they've allocated, the amount of memory, etc. Those sorts of key parameters. We can actually provide you with even more detail than that though. We can actually select the host tab here. It will provide you with a bit of breakdown in terms of CPU utilisation, percent ready and percent swap weight. So again, we're helping you understand where the problem lies. But again, you can get even more granular detail by going into vCenter at that point and understanding more about how that particular VM is performing. So that's a quick snapshot of the system itself. Now, presumably when you last wrote your blog, this was the kind of stuff that you saw in there before. Okay.
I would have one question, like, for example, I saw that we can pin one VM to the flash.
Absolutely.
And how about if that VM has a two disk, one system disk and one data disk?
So if I click on the virtual disks tab here, I'm just going to go back to the IOPS tab. What you'll see here is we're showing for this particular virtual machine, you can see there's actually a couple of SCSI disks defined here. So if I select this particular one here and give it a chance to update, what we can do is we can start to drill into the actual at the VDisk level, and then we can pin an individual VDisk to flash. So you can choose to pin the whole VM to flash, or you can just actually select an individual virtual machine. This system's actually running in California, so we're relying on sharing bandwidth with lots of people here. So yeah, so I can just right click on and just pin that. I'm not going to do that today, but that's how simplistic that is. So normally what we'll be looking for there is this particular virtual disk. Its latency is, as you'll see here, there's very little latency across the system, full stop. But if we were seeing, say, high back-end disk latency,
how are we doing over
this
there?
means we're accessing whole blocks of data from the spinning disk rather than the SSDs, and that would then start to indicate that that's the candidate to be pinned to flash. It's not, but the system itself does a pretty good job of auto-allocating resources, so you won't always necessarily choose to pin. The classic type of pinning, you might have a virtual machine that you only use, say, once a month. There's a specific job you run monthly. What you'd find is with the Tintri system is all of the data for that specific VM would likely have migrated onto the spinning disk because it hasn't been used. It's now cold data. You're ready to run that specific VM. You actually want to bring that and make sure it's going to be serviced from flash. That's the point where you pin it.
How big is the flash storage?
The system itself has got 2.4 terabytes of SSD storage on there. However, we decompress data into the SSD, so it feels like a much larger pool of storage. But going one stage further than that, we also have an active working set calculator in there as part of the software, and that works at 8K block granularity. And as a direct result, that combination of delooping compression combined with working set analytics, we're able to ensure that we only service those hot blocks of data from SSD. Most efficient usage you'll get.